Let me make sure it all works. Good to go.
Yeah, we're good to go.
All right.
Cool.
Well, my name is Ginny Panizzo. I work at the University of Nottingham in the UK. And I am originally a paleoecologist, but through my studies in paleoecology, obviously very rooted in contemporary ecology in terms of understanding how things have changed in the past. So, can't change slide. There we go. So yeah, I'm mainly, can you see my mouse?
Yeah.
Yeah, so this is me and my kind of first foray in the field, coring crater lakes up in Uganda, which were at the foothills of glaciers up in the Ruwenzori National Park. So trying to use lake sediments to understand how climate and in more recent years anthropogenic activity is maybe impacting on lakes. And I use aquatic algae called diatoms, which are siliceous, which preserve really nicely in sediments because they're basically made of glass. And I use these to understand how the ecology has changed, and that's very much kind of dictated by the main controls and drivers on lake systems. So depending on where you're situated, it could be whether it's colder or warmer, you know, if it's glaciated and it has a period of ice cover, how the lake turns over and when the nutrients are delivered, that kind of thing. So there's quite a strict environmental control on how the ecology adapts. And based on my kind of work doing that, I've become increasingly more interested in how the contemporary environment kind of shapes that knowledge for us to be able to reconstruct back into the past, whether it be, you know, 500,000 years, 200 years, etc. And as part of that more contemporary research, I started working in the tropics a lot more, mainly because I got a bit fed up of being cold and working in really cold environments like in Siberia and in other parts of the world. So I now predominantly have been working in the tropics and collaborating with many different practitioners and scientists. So here's just some snapshots basically of me in the field. So this is us coring a reservoir lake in northern Vietnam. I had to hang off the side of the boat to be able to get the corer up without it kind of falling because it was pretty heavy. And this is our team who I work with in the Red River. And they're mainly based at the Vietnamese Academy of Science and Technology. And we've been working with them on a project which I'll talk to you a little bit about on the Red River Delta, which has led to this now project, but this Living Deltas Hub that I'll be kind of referring to as well throughout this talk. So in terms of the kind of ongoing research that I'm doing, it's very much kind of collaborative and transdisciplinary. So we're working very much with local scientists and with local stakeholders. So these are the Department of the Environment in the Mekong Delta, and this is one of their monitoring stations on the Mekong River itself, which we took a boat out to visit last July. So that's part of the Living Deltas project itself, and I'll talk to you about that specifically in a moment. But we were trying to understand what they monitor from this station that they have in the middle of the river channel, how frequently can we kind of give them any additional equipment, for example, chambers to look at CO2 fluxes from the river surface, etc., to kind of help add to their repertoire of kind of monitoring parameters, so to better kind of understand the system and better implement things in terms of mitigating against anthropogenic and climate change impacts. So that's kind of a brief overview of who I am. Basically, I like to get out in the field a lot, which is good fun. So my main project at the moment, and what I will talk to you predominantly in this talk, is about living deltas. So it's a hub, and it's funded by the United Kingdom government, and it's under a funding scheme which is called the Global Challenges Research Fund, or GCRF as we call it for short. And the GCRF fund in its own right, so the government's kind of aim for this GCRF fund is that it wants to help address the UN Sustainable Development Goals, so these SDGs that the UN has put in place. And as part of that, they very much want hubs that got funded to work in partnership with researchers, local governments, international agencies, NGOs, and like any type of community group, whether it's kind of grassroots, etc., in developing countries. So it's really trying to understand what are the main challenges that these countries are facing, what needs to be changed, so this kind of theory of change, and how do we go about implementing this change and doing it in a holistic and encompassing way. So the kind of upshot of that is that hubs are obviously meant to be a way where knowledge can be exchanged and expertise can be exchanged, and whether that could be, you know, it's not just from the global north, it's very much kind of meant to be, you know, even in terms of local knowledge about places. And the ultimate aim is to make the world safer, healthier and more prosperous. So we have a number of SDGs which are central to our hub, and these are just some of us. So there are 50 partners which are involved in the Living Deltas Hub. This is just a picture of those of us who were able to go to our annual meeting, which was held in February, literally just before the UK called lockdown. So we got back within about a week of like the UK shutting its borders. Pardon?
Perché è una gringa.
So yeah, this is all here, and these are just the number of institutes that are kind of on the books, as it were, in terms of who's collaborating. But obviously we very much are working with kind of local stakeholders, local NGOs. These are just the people that were kind of in the funding application, but it's by no means exclusive to just these people. But you can see that it's working with people in India, in Bangladesh, Vietnam, Mekong, and people who work at the UN as well. So the Living Deltas Hub, so I've introduced a little bit about how it's funded and what the main aims of the funders are, and therefore why we're kind of doing what we're doing, and I'll go into a bit more detail there. So our proposals were put together to kind of tackle some of these UN SDGs. So here I just highlight some of them, but again, it's not exclusive to some of the other ones that other work packages are working on. But for my work package, ours are more closely tied to good health and well-being, in particular clean water and sanitation, climate action, and as you know, I'm an aquatic ecologist, so life below water being the predominant one. The Living Deltas Hub is working in 3 deltas. So the first is the Red River Delta, and I will talk to you in a bit more detail about that, because the Living Deltas Hub actually came off the back of a 3-year project we had at the University of Nottingham with our collaborators in northern Vietnam at the Vietnamese Academy of Science and Technology, working on the Red River, and this kind of propelled this kind of larger project which is being led by Newcastle University, so this Living Deltas Hub. So our research is ongoing in the Red River Delta, and when I say our research, it's very much our collaborators who have been doing this monitoring exercise for over the past 10 years, and they really are kind of pioneering the impact that it's had in terms of kind of informing policy with the Vietnamese government. We're also working now in the Mekong Delta, which, as I'm sure many of you know, is having some quite severe pressures put on it, not least because of transboundary issues with upstream kind of sharing countries for the river itself. And then in the GBM, so that's bordering India and Bangladesh. So we're working on both sides there, and obviously it's quite a large, very large river delta system, so it's quite a different kettle of fish, really. So they're quite different systems. It's quite a challenge to kind of make sure that we're developing monitoring exercises that can be kind of carried out and rolled out across the 3 of them, so we have a means to be able to compare and examine similarities and differences. So why bother with the Living Deltas Hub anyway, and the research that we're doing? Well, I think everyone knows really that delta regions are kind of susceptible to a lot of pressures, and not least is water quality. So it's deteriorating, and that's not just because of kind of the placing of large conurbations and cities and the kind of effluent that comes off them, including industry, the increasing use of pharmaceuticals and how we're finding all sorts of pharmaceuticals and agricultural pesticides in river waters now, which can kind of get into the food chain, and they can kind of bond with colloids and heavy metals and sediments in river waters as well. And changes in sediment load delivery, I refer to that mainly for the Mekong Delta. So we know that the Mekong Delta is really, you know, downstream in Vietnam, kind of getting sediment starvation, and that's causing severe undercutting of the channels, because it kind of forms eddies in the water column, and we're seeing kind of massive landslides in the downstream regions of the Mekong. And add that on top to increasing sea level rise, which I haven't added to this list, but again is a massive issue. You kind of see the confounding issue in terms of reduction in sediment load delivery and increasing sea level rise, so like kind of salinity in groundwater, etc. So yeah, transboundary competition for river resources. So here you have the Hoa Binh reservoir. So this is in the northern reaches of northern Vietnam, but the Red River has its tributaries up in China, and there are massive plans, particularly also for the Mekong River in Laos, etc., for the provision of dams to be put in to better manage water resources in respective countries, but that has huge issues for downstream partners. We're having issues surrounding the kind of variability in monsoonal delivery of precipitation, even in terms of how much, but also in terms of how there's kind of subtle differences in terms of when the rainy season is coming. And so, you know, that kind of reliance is becoming, you know, less, you know, the timing is becoming less apparent as to when it should be coming. And people who rely on that kind of delivery of monsoonal precipitation for, you know, agriculture, particularly rice agriculture, you know, it's becoming quite an issue. Top-down pressures in the Mekong Delta, it's quite interesting. There's a lot of top-down pressures there in terms of the local government kind of dictating what people should be growing. So because we're seeing changes in salinisation in terms of the groundwater and just general incursions of saline water, we're seeing the kind of local government asking people to move from paddy agriculture to aquaculture, and that in its own right has quite a different impact on how water bodies are and the water quality surrounding that, because, you know, they become quite eutrophic, and we have fish kills associated with them. The longevity of aquaculture and those ponds is kind of only 3 to 5 years, so you have this kind of quite transient destruction, I guess, and deforestation of mangrove to kind of build new aquaculture, you know, ponds, etc. In India, when I was there in November, you know, we discovered that there's quite a lot of cultural emigration. So a lot of young men will go to Kolkata, for example. So we were in the Sundarban, which is the kind of prime natural reserve of forest, and people who live on the outskirts of that. So they're very much living with nature. And so obviously the attraction of being able to go to a major city and earn a wage and get all the mod cons that are associated with that, like a mobile phone, etc., are very appealing. But that leaves women, quite often older women as well, at home on their own, trying to manage a small pond, maybe agriculture, or, you know, their kind of domestic scale agriculture. And if there are any issues that ensue, for example, from hurricanes, we just had another hurricane in the region which kind of devastated the area, you know, these women are left to try and cope on their own, and it's becoming apparent from our discussions with them that actually it's quite a challenge. So altogether, there's many pressures basically, which I'm sure you're all aware of, but the resilience of people who live in these ecosystems is kind of reducing, and it's very much due to these anthropogenic and climatic pressures. So we're trying to understand these better. And here you can just see, these are mainly, not all of them, but photos from my field work. So here you can see people dyeing batiks. So this is in the Sundarban in India. Here we have sand excavation, so dredging basically from the Mekong River Channel, and this is what's causing massive undercutting. Here you just see like local fishermen trying to just earn a daily wage and kind of live hand to mouth. We have the Hanoi city in the Red River, which is a huge source of effluent pollution to the Red River and a massive cause of kind of localized nutrient loading. Yeah, so and here we have people who use the river. This is in Kolkata for daily bathing. So, you know, to know that there are minimal fecal coliforms and it's of a decent water quality is incredibly important for these people. So there's kind of, you can really see that those who particularly live in the more rural areas like up here are really kind of dependent on this kind of fine line. So yeah, I talk about the kind of top-down pressures that we have. So here we just see a land use map of the Mekong Delta, and we can see that, you know, we have some areas where we have like orchards, but predominantly it's rice, so paddy agriculture. And so these people are really reliant on the kind of quality of the water, but also that it means that there is a huge amount of use of, oh gosh, what's the word? Fertilizer, there we go. So lots of fertilizers being used, and this is leading to quite severe nutrient loading with these channels and dikes kind of feeding straight into the main river channel itself. And we can see it sometimes even in coastal eutrophication, which occurs as a result of this. But because we now have this increase, particularly from this region, so the kind of southwest region, and from the south of the salinization, we see now that this drive to more aquaculture is occurring. So there are 6 work packages within the Living Deltas Hub, and the work package that I am most closely associated with is looking at how human impacts are basically changing deltas. So it's kind of looking at the kind of physical characteristics of the rivers and the other main water bodies, and trying to understand how they are changing and how we can try and kind of implement policy to kind of preserve them for future generations. It's not particularly clear there, sorry, but so the main premise of the Living, not Ling Deltas Hub, is that, you know, we're looking at socio-economic change, global environmental change, politics. We're trying to marry all of these quite complex, you know, interconnected elements within the different work packages, and at the same time we're making sure that we're trying to engage, which is a real kind of crucial element of the hub, is that it's very much not just us flying in and trying to put things in place, but it's very much working with local stakeholders and policymakers, so that it's very much a kind of co-developed solution, and they're driving the change that they want and expect. So the work package 3 that I work in is mainly focused in both defining natural baselines in terms of water quality, essentially, and monitoring the kind of shifts that we have within these deltas. So whether it be on a spatial, and as well we have complex seasonal changes that are happening, obviously, with, you know, monsoonal precipitation. So the main thing that we're charged with is trying to set up long-term monitoring in each of these deltas, and this has already been established in the Red River. As I say, our collaborators have been doing it for the past 10 years, but in parts of the Mekong and in the GBN, this is not occurring. So this is very much the challenge that we have, to try and make sure that local government is, you know, monitoring on a regular basis the water quality that they have. And it's quite important that we try and engage the local stakeholders with this. So we will be trying to do some citizen science at some stage, and I'll talk about that a little bit down the line. But essentially making sure that people are involved from the outset, so they understand what the point of all of this is. And it helps us to better inform and come up with a kind of more adaptive plan in terms of, we will be kind of modelling different scenarios of climate change to kind of test the system, for want of a better word, in terms of how it will respond to kind of increasing, you know, changes in precipitation, changes in temperature, and changes in sea level. part of the way that we're defining these baselines, and this falls back to the kind of background that I have in paleoecology and paleolimnology, so that's the use of lake sediments to kind of reconstruct history, essentially, is that we'll be looking for floodplain lakes, and we'll be drilling them and looking at how they've changed in the past and how they're kind of changing in the future. You know, we'll be able to then model how they're changing now, and then you know, test their kind of ability to withstand some of these pressures that we're having. So we're moving from these kind of ecological systems, so these SESs, to these SESs, so these socio-ecological systems now. So because we're having increased human control, we're having increased kind of human dependence on these ecosystems, then they're becoming quite a different system. So, and they are changing, they're becoming more and more vulnerable and susceptible to the risk that's being posed to them. So my particular research focus in the project itself is to help develop these water quality databases that we'll have, and hydrological databases, and whilst some of the local governments do have kind of discharge data or maybe TSS data, there's not much other data that's around. And in particular, we want to try and look at kind of ecological data, because this can give us quite an insight in terms of how the food web is functioning, and also how sensitive it is to, you know, whether the main drivers are more kind of sediment based or perhaps more kind of nutrient loading based, if you like. And via developing these networks and these kind of monitoring networks, it also provides us an opportunity to do some citizen science, but also to provide some kind of knowledge development with our collaborators in terms of the skills that we have and the skills that they have, and understanding some of that kind of local ecology, perhaps, which we might not have been so clued up on before. So here we have an example from the Red River. So it's quite a complex drainage system, and there's a number of different rivers that kind of feed into the Red River Delta itself, so it's not just one river. And here are the sites that we've been monitoring. Well, we've been doing it for the past year, but our collaborators have been monitoring these sites monthly for the past 10 years, so it's really quite an impressive data set that they have, and they've been monitoring quite a number of different parameters. So there's a number of different tributaries. So these D sites form the Day River, whereas these H sites are the Hong River, and they kind of interconnect at different kind of spatial transects. But there's quite a number of different land uses that we have within this region. I mean, as you can probably imagine, further upstream, I mean, this was that reservoir that I showed you before. So it's much more kind of agricultural, kind of like plantations for fruits and stuff like that. Whereas when we come further downstream, it's very much more paddy, so rice cultivation, but also you have the city of Hanoi, and that's a huge city that has quite a lot of, has very poor drainage systems put in place. And so when we have the floods, essentially most of those sluice gates that they have imposed around the city get opened, and a lot of the wastewater just discharges into the Day River. So here I am with some of our collaborators. So this is when we did before we started our project on the Red River, we went for a kind of an inception meeting, as it were. So this is Twee, so she looks at the aquatic ecology within the river system, so the phytoplankton, and she's been working in this region for a long time, and here we're just kind of harmonizing methods. And here we're sampling for chlorophyll A, I think. So they've been measuring numerous physiochemical parameters, as you'd assume, TSS, cations, anions, different types of nutrients, phytoplankton and algal biomarkers. So I look at pigments using algal biomarkers, different types of zooplankton, overall productivity in terms of the phytoplankton biomass using chlorophyll A, and then we start to look at your carbons, which, as you can imagine, in these big river systems is very complex, but also incredibly important if you want to try and understand about carbon sequestration in light of climate change as well. So here I just have some I just thought I'd show a little bit of data because I thought it might help. These are just some ordinations, and I'm not going to go into too much detail, but these are elements that we have, particulates from within the river systems. This is from the Red River, and these are some of the different river channels that are there. But we can basically see that we have quite distinct differences, as you would imagine, in the wet season and the dry season. And the Day River is very, very susceptible to this influx of basically nitrogen and organic carbon from all the sewage, basically, that gets poured out through the system in the, particularly in the wet season. And you can see that again here in the wet season. You can just see how the Day River is located very closely to the amount and the highest amount of total nitrogen that you have in the river system itself. And this is particulate carbon as well. So, you know, we can see that there's also different elements which are associated with, and we're just trying to disentangle this now, actually the prevalence of industry. So in some of these regions we have increasing industry, for example, zinc and copper mining. We have different craft villages, which could be anything from battery recycling plants to pharmaceuticals to you name it. So we're trying to now look at this to fingerprint what are the main kind of pollutants that we're seeing in the river as a response to the industry that's located there, and how does this change between the wet and the dry season. But you can see that, you know, in the wet season is very much where we're seeing the prevalence of these elements coming into the river system, because they're being flushed through it, whereas in the dry season you see a lot less of them, but we still see high amounts of nitrogen. And these high amounts of nitrogen are really responsible, therefore, for kind of these phytoplankton blooms that we have. And here, these are just the different number sites that we have going downstream. So H being the Hong River, which was kind of to the north of Hanoi, and D being the Day River, which is south of Hanoi, and which is basically where all the sewage comes in. So we can see that particularly in the dry season, so here February up towards kind of July is the dry season. So we're seeing that we're increasing productivity that's arising in those dry seasons, mainly because it's less dilution that you have, because you can imagine that the discharge is massive when you have the monsoonal system. So compared to the wet season, there's less dilution that we have, and this gives the ability more clarity because you've got less, you know, suspended solids as well, so there's more opportunity for algae to bloom. And we know that the Day River has got a higher prevalence of blooms because it's got not just the presence of this sewage element from Hanoi, but also we see lots of agricultural fertilizer being used in the region due to the paddy field. So again, that's promoting, this nitrogen is promoting these blooms that we see. Our other colleague in Hanoi, Na, she works very closely with these horrible models. It's a material, I say horrible as in it's a mess, it's hard to disentangle. Obviously it's a fantastic model in terms of its ability. So it's called a material flow analysis, and it's basically a way to very complexly try and her particular focus is on nitrogen, which is why I've been talking a little bit about nitrogen. So as a means to try and model where sources of nitrogen are coming from, what type they are, whether it's an inorganic or an organic nitrogen, and how they're flowing between each of these different systems. So, you know, she'll start with her surface water channel, which is the main kind of output that we have of where this nitrogen will be going, because you have the monsoon, everything's flushing through into the river, so that's what she's interested in as an output. The other output is how much is being degassed and set up into the atmosphere, so it's a kind of nitrogen loss via that way, and how much is kind of being buried essentially into the soil. So they're the kind of three outputs that she has. And so she goes around conducting household surveys and asking people what they do literally with their kind of pig waste, and what they do with all of their scraps of food, where do they get their water from, you know, where is their toilet, if it's not in a conurbation, obviously, if it's in a rural village. And she'll go through and she'll kind of be able to quantify the amount of nitrogen that would refer to and the type that it is, and she'll kind of model it through the system. And on the basis of that, she can basically come up with these kind of figures where she can see that these are different provinces in the region of the Red River. But you can see that Hanoi this is the amount of nitrogen in tons kind of lost to the river system. You can see that Hanoi obviously is the largest kind of contributor of nitrogen, and that in that region it's mainly from paddy fields, so this will be fertilizer use essentially. And when she looks at it within the paddy field itself, she can see that it's essentially chemical fertilizers and kind of drainage from the river system itself, so like from other fields which have got high quantities of nitrogen, which are kind of the main source of nitrogen. And then our other collaborator got a bit more fancy by looking at the isotopes of nitrate, so looking at the oxygen and the nitrogen isotopes in their own right. And that's a very clever way to try and fingerprint that source. So whether it's from a chemical fertilizer, whether it's from manure and sewage, essentially this is the effluent from Hanoi, or whether it's from the soil or from just background sources from the river itself. And what he found is that basically in the dry season, you can see that because you don't have as much paddy season growing, because it's not wet, so that's when there's kind of fallow. It's mainly the nitrogen in this Day River, so that's that southern tributary, is just basically because of sewage from Hanoi. But when we get to the wet season, where we start to see the prevalence now of paddy agriculture, because that's when the season will start, we can see that we have an increase in the amount of chemical fertilizer. It's July is when it starts. We see the increase in chemical fertilizer being used, and in the dry season it's kind of a balance between the two. So you can start to even kind of model and also literally isotopically measure what those sources are. So that's an example of what we have been doing in the Red River, and that kind of is essentially the kind of thing that we'll be continuing to do and starting to apply in the Living Deltas project. And unfortunately, we were supposed to start all of our monitoring in April with one of our postdocs going out in India to start that and help set it up. But obviously due to COVID, you know, different countries have been hit quite severely. So India and Bangladesh have been hit quite severely. Obviously everything's been put on hold for the moment. But I mean, the outputs, you've seen some of the kind of more research-based outputs, but essentially what it's also showing us is the kind of quality and the health of the rivers themselves. And as a part of that, we want to set up these kind of yearly report cards, environmental report cards, which will be able to be disseminated to local stakeholders, and in a way and produced with the local populations, so they'll be communicated in a way which they can understand, like they can tell us what is important to them to know about the quality of, rather than us going, oh, I like algae, that's really important, you know, let's look at the health of that. So it's very much dictated and co-developed by them. But we can divide the system into kind of geology, biology, or hydrology, however else you want. This is just an example from the Tennessee River, obviously. And then we can try and quantify the health, or like how good the system is doing, so much like the European Water Framework Directive that we have set up in the UK. But these are kind of more forward-facing ways for people and local stakeholders to kind of understand what it is that we're doing. And then you can create like a more wider regional health index, for want of a better description, of how these different parameters are performing. And it could be compared to the wet and the dry season perhaps, because for example in the Red River we do see quite distinct changes there, and it will help inform in terms of management what the kind of choke points are in the system. So as part of that, as I said, a lot of this would be co-developed, and we do want to develop citizen science. Again, we were hoping to apply for the kind of BioBlitz fund for the National Geographic over the summer, but obviously we won't be able to do any fieldwork. And we wanted to pioneer it in Bali Island, and this is Bali Island in India, in the Sundarban, where I went in November. And here you were really, I was really impressed by the importance of ponds. So here you can see this was following one of the hurricanes that had happened a couple of years ago. A tree had basically fallen into the pond, and it basically starts to decay, and you have decreases in the amount of dissolved oxygen, and everything basically starts dying, and it's just been left to kind of empty. And then these are the kind of other more turbid ponds that we have, and you know, that have quite bad cyanobacteria blooms because essentially they're becoming more and more eutrophic. So we were really interested to try and understand how and why people use these ponds, and obviously because they use them for a range of different factors. So, you know, for sanitation, for aquaculture, it could be for potable water, so for using in the kitchen, bathing, washing. They're obviously very, very crucial to these local populations. So we'd like to try and do a little bit more of a BioBlitz and some other citizen science around these. So we're developing that at the moment. And all of these elements will feed into essentially the ultimate aim of our work package, this Delta Health Index. So Volmer in 2018 developed a freshwater health index. And the idea is to kind of do a very similar thing in these Delta regions and these Delta SESs. So it's, again, kind of building on from these report cards, but looking at how healthy the system is. But it will also take into consideration not just my interest in work package 3 being kind of ecological, but also how the people are interacting and kind of cultural and historical aspects as well. So it's very much how different people identify with the Delta will be quite different depending on how, you know, how I would identify with it would be quite different to a cultural historian or cultural scientist or a historical scientist. So yeah, that's the main aim. So kind of be looking at overall being able to then inform better for governance and stakeholders. So that's the ultimate aim. So what, as a whole, as a hub, what we hope to do is to try and develop more kind of equitable livelihoods for Delta dwellers and make sure that management practices will be much more sustainable and not just and kind of on different scales, so on a more local scale, but also a kind of landscape scale. It inevitably will need to be low cost. So, you know, it's all fine and dandy us in the UK saying, oh, we need to set up monthly monitoring programs. But when you're looking at the Indian part of the GBM, which is absolutely massive, and it takes 2 weeks to do, you know, sample 8 to 10 sites, that, you know, it has to be low cost and it has to be manageable and something that can be rolled forward, much has been the case so far. Many of these projects have happened and there's been a flurry of monitoring, particularly in the Red River, but the minute that funding and that project is gone, the local Department for the Environment can't sustain that and will just, you know, resort to what they were previously doing. So it's about putting something in place with them that we know that they can manage and that will be sustainable. As I've mentioned, we want to develop this Delta Health Index that can be used for policy, so it'll be quite strategic planning, and want to make sure that these policies which are put in place, you know, are important both at the local and the national level, and that they're quite empowering in terms of protecting youth and women who, for example, in India, as I gave one example previously, you know, can be quite marginalised due to emigration from the region. And of course, we must fulfil and make sure that anything that we do advise is kind of driven by the Sustainable Development Goals, and that's we have a separate work package that is just working towards that. So that's very important to us. But I'll finish there. Thank you.
Cool, thanks, Jenny. That was impressive, and I'm really impressed how so many things come together in this project, and barely can imagine how you start with this project. Like, who got this idea, and how does it grow from a very basic...
So it kind of stemmed from the smaller project we had in the Red River, and we were working with our collaborators for about 3 years, and then our friends over in Newcastle University were starting to think about this GCRF hub, obviously, because, you know, it's up to £20 million these bids. It's quite a huge project, and yeah, wanting to be a bit more ambitious, and yeah, quite liked the success that our collaborators had. It's very much our collaborators, not us, you know, in terms of being able to implement all of this monitoring and the outputs they'd had in terms of understanding, you know, nitrogen flows and being able to inform local government about the kind of impacts that it was having. And yeah, it kind of stemmed from there. Next thing you know, they start thinking about Mekong Delta and the GBM. So yeah, it's a very ambitious project, but the PI is very passionate and very, very good at keeping people to their task, and you know, is very keen on this co-development and, you know, knowledge sharing. So yeah, we're being kept under tight, you know, a watchful eye.
I see Jens asked quite some questions in the meantime, and he wants me to ask them because he's in a bad internet connection, but you can read along, I think. First one is the hub Europe focused, or do you consider alliances with countries on other continents? Obviously in Asia, you've got some alliances, I would say, right?
Yeah, so I'm just reading it as well with you.
Yeah.
No, the hub is not Europe focused only at all. Do you mean in terms, Jens, perhaps you mean in terms of the people who are funded in it, who have, you know, who are the co-Is? So no, definitely not. It was very much developed with each of the country partners. And no, the Delta Health Index isn't developed yet, so that's part of what we'll be developing. But the Volmer paper, which is the Freshwater Health Index, is, you can have a look at it. We kind of just adopted the idea to apply.
Yeah, because that's being applied worldwide already, right?
Yeah, I believe so. And we've talked about it, I know, before, Vera. So yes, but eventually, yes, this will be published. And I hope it can help to be a conservation tool in a way. So, well, I guess that's the ultimate ideal. But so in the Indian and Bangladesh parts of the GBM, you already have like a Ramsar site. You've got the Sundarban, which is completely protected, and that's where the Bengal tiger is. So we can't conduct any research on any of the land there. You can't enter it. It's a national park. So that's also why it's so important, you know, to try and maintain the quality of these waters, because there's such diverse there is diverse biodiversity there that we're trying to preserve, essentially. And even how local livelihoods rely on that Sundarban is quite interesting. So you might have noticed there was a picture of a crab that I had in one of my first pictures. Basically, the local people will sneak under the barrier and go into the Sundarban where the Bengal tiger is for crab fishing, because there's a huge demand on price in China and in Singapore for these crabs for eating, essentially. So people will literally risk their life. And when we were in India, we were talking to a local stakeholder, and he had to stop the conversation because he got a telephone call because someone was being mauled by a tiger, because that's exactly what they'd done. They'd gone under the rope and the netting that they put up to go crab fishing, and basically was hanging out of a Bengal tiger's mouth. So yeah, bit of a adjunct there, but
reality.
Okay, other questions from Jens? Thank you, Jens, for your questions.
It's just continuing.
Yeah, it's good. Yeah, so there is, the Red River is Red River because it does have like a red sand from the geology. So yeah, that's essentially why they call it that. And it's particularly in the wet season months that you'll see that. And you can kind of make it out from maybe that reservoir picture that I had. I can't remember if you can see it, if it's a bit red in there.
I think the red color you saw though was a ship, right?
Yeah, so there's ship, that was from the Mekong. Well, you can't really, this is the Red River, you can't really quite make it out, but it is essentially to do with the colour. Yeah. Yes, and there is most definitely cultural components. Yeah, I'm just talking about my little pet project, literally, which is all the ecological side. Yeah, so we have, where is it? All of the other work packages. So this is a huge part of the project. So we have people looking at the heritage and the livelihoods of people in the deltas. So it could even be how people share history, you know, whether they sing or they perform art, whether it's in plays or however else. So there are people who literally have their research just focused on how that knowledge is shared through generations, and in a way how it's being lost because you have these generations leaving the delta to kind of change you know, they've got different ambitions and they've got different aims in terms of career that they have. Work package 2 is kind of looking more at like risk associated with you know, the impacts of these delta SESs. Work package 4 is looking at mangroves, basically in carbon loss in mangrove systems due to kind of decreasing sedimentation that's happening because of, you know, reduced downstream inwashing of sediment, and also due to sea level rise. Yeah, and obviously work package 5 is very much about applying all of what we're doing into these sustainable development goals. So that's, yeah. What other thing?
He's asking whether the local stakeholders are interested.
Yeah, so for part of our, well, we were supposed to have a huge end of project workshop with basically people from the government in Vietnam, and so like the ministries in the northern Vietnam region for the Red River. They were all supposed to come over in April, just after Easter. We had a load of policy documents that we were going to inform on them based on our research, and I've just given you some snippets here to advise them on what would be good for them to monitor regularly, you know, which would also involve the collaboration of our partners in their institute, which is partly a government institute anyway, the Vietnamese Academy of Science and Technology. But yeah, unfortunately that couldn't happen. But we are trying to make sure that, and this is actually a discussion we're having at the moment, so we're trying to implement participatory fora, and we need to decide what it is that we want to implement, what change we want to implement, and making sure that we invite those stakeholders, whether it be local government or maybe like a local NGO, like from the outset, so that they understand what it is that we're trying to do. They can tell us what's manageable, and we can try and implement that change. This is it's a 5-year project, so it's long, but it will fly by. So yeah, that's the aim of being able to feed into management. But again, it will completely hinge on money, you know. So we have to make sure that what we propose is realistic and manageable, and not just us in the UK getting excited and, you know, proposing doing this on a monthly basis. It's like, do you need to do it on a monthly basis? Is seasonal enough? That kind of thing. So it's, yeah. Is
the focus on monitoring so much so that like kind of the idea is that they really come with solutions themselves instead of really proposing solutions?
It's a good question. Well, I guess there has to be an element of us based on, I mean, and I say us, I don't mean UK and Europe or, you know, everywhere else. I mean very much everyone who's on this project, and particularly the local in-country collaborators, because they know best how all of those cultural sensitivities in terms of how, you know, the different denominations of government devolve from each other and how they all kind of connect, and, you know, it's very different systems in each country to how it operates in the UK. So, sorry, I digressed there, I forgot.
No, the question was whether I'd like to focus on monitoring is to make...
Yeah.
Yeah.
Thanks. So, yeah, so I think being able to advise based on some of the monitoring, yes, I think we have to be able to demonstrate something that shows them the value of the monitoring, and then based on that we can advise collectively what would be good to implement for management. Yeah. So, but, you know, we've got examples that we can show them already. We kind of already know what might be happening, so we can try and start doing that from quite early on, even with like pilot data. So it's not just like, here's 4 years worth of monitoring data, this is what you need to do. So yeah.
Cool. Is there one example you have of a thing you learned from the local communities that you thought like, that's actually a smart or a good observation that I've never really thought about?
Oh wow, that's such a good question. Oh, I can't think of anything now, but most definitely there is. Do you mean in terms of my like research, or just in general?
Well, in terms of your research would be super cool, but I guess that's like... in general is also?
Oh God, I can't think of anything, but there most definitely are. I mean, I'm always learning stuff whenever I go on any of these fieldworks because it's so diverse. And yeah, I mean, the trip to India in November was a real eye-opening experience. You know, really witnessing how people are living. I mean, it's stunning, but you know, they have nothing, but they have everything. You know, so. But the thing that really impressed me was how the women struggle and but equally how they survive. But because all of the men are leaving essentially and going to Kolkata, and they'll work there for 6 months and they'll come back. So if anything happens, like the example of that tree falling into a pond and basically starting to kill the pond, you know, if a woman in her 60s is at home on her own because her husband's gone to Kolkata for work, you know, she can't get the tree out, so then she has to pay someone to help her get the tree out. She doesn't have much money anyway. So it was more impressionable, I guess, in understanding how the priorities of people are so different. And I think that those are the cultural sensitivities which are very important to try and consider. You know, it's all fine me going, oh, what's the algae doing? But it's like, what do we need to know? What's going to be important for people, not just, you know, blue skies research, like understanding it and wanting to know it for the sake of it. It's, you know, what is the main output that we want to get here? What's going to be useful for people? And I think that's the key. It's kind of turning our science upside down, really, in terms of how we perhaps normally operate. And I think that's been the most eye-opening experience.
Yeah, super impressive. Cool. I'm curious if somebody else still has other questions. You might have realized we're pretty much here with our team. I'm just going to introduce them really quickly because I think it's cool that they're all here. And it's a pretty, like, honestly, I expected a few more people.
No, I don't mind. It's fine.
But you have Jess here. Yeah, you met her in the talk with Najib already, right? She's working on a turbidity sensor.
Yeah, that was it, yes.
Cool. Semra, she's from Montenegro, actually. Yeah, that was a real quick hi. But she's helping us a lot with the student service camp. Unfortunately, we cannot be doing it there. So in that sense, logistically, it will be more online than that. But she's a huge help there. And Ellie is tuning in from Austria. Not sure if she's listening.
Hey, can you hear me?
She might still be in the office. But I think this is an impressive.
Hello?
Yeah, we do hear
awesome.
you.
I just quickly wanted to say a big thank you. I was biking home from work, so I didn't hear everything, but it was super impressive, and only the last few lines made me realize how much I miss going places. Like, I think it's super important to get this cultural experience.
Yeah, I think.
Anyways, thank you so much. Unfortunately, I have to leave because we are renting our apartment and it's a bit hectic.
Nice to meet you. Thank you.
Ciao.
I have one last question before finishing up, because you're working together with some universities there in India also, right? How do you feel the level differences? Is there some qualities that we don't have, otherwise do have, or is it really, can you see like, okay, the UK is just a step ahead? Like,
you mean in terms of like resources?
Resources, but also really quality of research in the sense of like quality of education, even what's the level of students?
Well, the people that I'm not working with any students. I'm just working with you know, academics and postdocs. But yeah, by far they definitely know what they're doing and very, very knowledgeable. So it's and also for my Vietnamese collaborators, like they really, really know what they're doing. So yeah, it's exciting. It's good. The only place where they struggle, less so in Vietnam, because our collaborators are very, you know, they're doing really, really well. So they're you know, applying for lots of bids and stuff, which is kind of how we got our grant in the first place. So you know, being able to apply for funding to buy equipment and to keep their labs going. But in India, it's the minute they have a project, if the funding goes, then they might lose. So they might have equipment bought for a project. But the minute that project ends, that equipment might go to a different a different lab. So, you know, they used to have an ICP-MS, and a lot of the things that we want to measure they could have done in-house, no problem, but now they don't have one anymore. So it's more capital in terms of being able to buy equipment, which is the issue, not at all like knowledge exchange or anything like that. So yeah, I'm learning from them, you know, when it comes to researching in their respective fields. So yeah, very much so.
Cool. That's good to know. Because there's often, I think, a bit of a perception. I don't know, like learning that ourselves, right? Somebody's joining now for the last 1 minute, maybe an hour late. But yeah, cool to realize and to really have it at a similar level, right?
Yeah, definitely. And I mean, inevitably, because of the capital, they won't be working on, you know, so I've researched in Antarctica, Siberia, Northeast China, Malaysia, you know, whereas their research focus will probably be on their doorstep. So they are the people you need to tap into because they know everything about those systems. So yeah, definitely, they're very knowledgeable. And I found that very much the case working in Vietnam, Malaysia, India and Bangladesh. So yeah.
Cool. Yeah, some memories come back from you. I was in Bangladesh for 3 months, pretty much, for a study project back in days, which was also a lot to do with drinking water. So I saw a lot of ponds and how people act around it, and pretty crazy to see, but also to see how people indeed just manage around it and how you can come in and really think like, that should be changing that. And at some point you realize, okay, no, actually it's working quite fine.
Yeah,
it's cool. Yeah, it's 7 now. I would say let's finish off, unless somebody has some other questions, ideas.
I don't. I'm sorry. But it was super interesting talk. And thank you very much. And
yeah, I really hope we have connect more during the.
Pardon?
Sorry, I was talking through you.
No, I was just going to say, normally we have a lot more participants. I think, at least here in Switzerland, there's no lockdown. I think most people are now outside and finally enjoying being able to go outside. Yeah, Jens says stay here.
Yeah, everyone's outside.
But thank you anyway, it's super interesting.
No worries.